I'm Mike. I'm from this place called Google. Anyone heard of it? If not, you can do an internet search for it. There's a website. Yeah. I swear that's as funny as I get. That's it right there. I'm done. Yeah, so I'm a machine learning cloud consultant. So what does that do? I go from customer to customer, and I help them be wildly successful with their machine learning problems using Google Cloud. But I'm not going to talk about Google Cloud at all today. Instead, I'm going to be talking about bias in data. This is a near and dear topic to my heart. I've been in the data science game for a while. Before this, I was the lead data scientist at State Farm. And in my time, I've really become passionate about this topic, and I hope by the end of my talk, maybe you'll be passionate about it too. As data scientists, we probably want to think about, this is kind of a little bit of a straw man, but bear with me. We would like to think that our data is objective and cold and the base truth, and that we can trust that and we can do great science from this cold objective fact. But that's really just not always the case. And what I'm hoping to do today is show you some times when that's not. And this isn't really a new problem. So this is one of my favorite examples. Until 2011, we didn't use female body type crash test dummies, right? It wasn't a thing that was required. Also, until 2011, the probability of a woman being severely injured in a crash was 47% higher than a man, assuming they were both wearing a seatbelt. Men are terrible at wearing seatbelts. Yeah, so that's a problem, right? So this is an example of a bias in data that leaked in. And it wasn't probably malicious or intentional, but it just found its way in. And people got hurt because of it. This is a little bit more creepy. So there's this program called Compass, right? And it's a predictive model. And what it does is it predicts the probability that someone's going to reoffend if they've committed a crime and they've been sent to jail. And so this is used to determine the next step for someone, should they be paroled or not. And what happened, ProPublica did this analysis of this. You can Google it if you want. What they found out was this confusion matrix, right? Labeled lower risk, yet did reoffend. 47% white, 28% African American, right? Huge bias there. Real people get hurt by biases in data. So, okay, where does bias come from, right? And today I'm mostly zooming in on data, which in that bias comes from collection and annotation. But it can also come in the model, right? Our architecture choice can bias the results of a model, or loss functions, or the metrics. And deployment, how we use the model, can also bias the results and the predictions. But really what I want to get at is that unconscious bias can leak into all of these places, and it's up to us, the practitioners, to know that, understand that, and maybe mitigate it. This is a quote that I really like. I hate to read slides, but I'm going to read this just for a second. Bear with me. Every data set involving people implies subjects and objects, those who collect and those who make up the collected. It's imperative to remember that on both sides we have human beings, right? And that's kind of my call out today, is to remember maybe things aren't as objective as we think. And so that's what I'm asking you to see, is that data isn't neutral, right? I wish it was, but it's not. I'm going to talk about 3 different biases today: sampling bias, human reporting bias, and implicit stereotypes. I'm going to give you examples on how they all can be seen in data. There's a lot of text on this slide. How many people here have ever used the data set labeled faces in the wild? Okay, I see 1, 2, a few of us. Labeled faces in the wild is a common data set used for facial recognition, right? And it's common because it's used for, it has pictures of people in real life events. And it turns out that that data set, it's 77.5% male, and it's 83.5% white, right? So that's a common data set that we build a bajillion, that's a technical term, different models off of, right? It's one of those things that we bootstrap off of, and there's a bias in it. And it's not the only one. There's a couple of other computer facial recognition data sets like this as well. But let's go to image classification instead. By the way, all this work is from Emily Denton of Google Brain, who is amazing and was really nice and let me use her slides. So thanks to Emily. So yeah, so probably everyone's used ImageNet, right? Or if not, you've used a model that's transferred off of ImageNet. Transfer learning's cool. If we look at that, where do the images in ImageNet come from? Almost half of them come from the United States, right? So there's a bit of a bias there in location. So image classification isn't immune to this. Now, what's interesting and what I want to call out before I move on is that with the example of the crash test dummies, right? There was a bias in data and it was having this problem. That's kind of an old school bias problem. A new school bias problem is that we build machine learning models on top of biased data. And when we do that, we have an amplification effect, right? We all know that machine learning is a force amplifier for decisions. And those decisions get made faster, and we can make those biased decisions at a level we've never seen possible before. All right, so let's talk for a second about human reporting bias. This comes up more in data labeling, but we'll see some examples. Gordon and Van Durham, what they did was they took a whole bunch of written English words and they did a word count, right? So this is like Spark 101, MapReduce 101. And what they did was they came up and found that like across the English corpus that they had access to, 11.5 million times we said the word spoke, and 3.9 million times we said the word laugh. Okay? Seems okay so far. What I want you to see here, though, is that we said in this corpus of text the word murdered 2.8 million times. But we said the word exhaled 168,000 times. So what? Well, so what is we exhale way more than we murder, I hope, right? But this is an example of reporting bias. And what it means is we talk about things at a different rate than they actually occur. That's all. There's nothing especially insidious about this. But these kind of things do leak into our data. And how many people here have used word embeddings? Okay, way more word embeddings, way more NLP going on here than facial recognition. That's probably a good thing. So word embeddings are a way to compress language into a reduced dimensional space so that words have relations to each other. And if none of that means anything to you, that's okay. What is important is that we can teach the computer to play these cool games like man is to king as woman is to queen. Okay, seems all right. Sister is to woman as brother is to man. Yeah, okay, that sounds right. Man is to computer programmer as woman is to homemaker. Wait, hold on. I don't think that's okay. And where does that come from, right? That doesn't come from a awful modeler or bad intentions. Where that comes from is the computer learned that from the data, right? And and this is the reporting bias of the world that we lived in the world that we live in now, being carried forward into a word embedding into a model that could be used in an NLP application for something completely unintended. And this is something we need to watch out for. All right, so let's play a game. What do you guys see here? Bananas, yes, you are an effective image classifier. Okay, let's try again. Plantains, okay. Anyone say green bananas? Yeah, okay. I'm gonna go with green bananas or unripe bananas. Right, so bananas, unripe bananas. People tend not to mention the prototypical aspects of an image, right? We don't say yellow bananas, we just say bananas. And this becomes problematic. For example, in reporting bias, when we label images, we might see a doctor or a female doctor, right? And that's not right. We've put a bias in here just from our implicit understanding of the world. All right, so lastly, I want to talk about implicit stereotypes. And these are things that come especially from the people that are labeling your data or the processes that are labeling your data. And you know, if you're using a data labeling service, this kind of thing is especially something that you should watch out for. So an implicit bias might be, there's a man in medical garb, well, it must be a doctor, whereas if we see a woman in medical garb, we assume it's a nurse, right? These are two labels that couldn't have come back from a labeling service, and this is something that you need to watch out for. So that's a lot of doom and gloom all at once. I hope it's interesting. Before I talk about what we can do, show of hands, just kind of curious, like how many of you were like, yeah, I knew this existed? Okay, a good amount. How many of you are like, okay, maybe I didn't know it existed, but I'm convinced it's a thing? Yeah, maybe, yeah, okay. How many think that I'm just totally wrong? Okay, good. No one. There's no one from Amazon here today. I kid. All right. So what do we do? This is what we call a call to action. Right. So the first thing is I'm asking for us to agree as practitioners, as data scientists. I want us to all recognize that data isn't really neutral, right? And as much as we would like to believe that we're working on some cold, hard-based mathematical thing, it's not. And so then here's my second thing. We need to be really skeptical of the data that we use and of the models that we build, right? And when I say of the models that we build, because they're built on data. Of course, there are other places, and I talked about some of those, where we can, where biases can leak in, right? In fact, that's a whole different talk. But be skeptical of your models, be skeptical of your data, and test. One of my favorite ways to test, to understand bias, is if you have a test set that you're already testing with your model, divide that up into demographic bins, right? And test and see if your error and your performance is the same across those bins, right? It's a real simple test, doesn't take too much longer. And then, so here's the last one. It's my last request. Let's use AI or ML. The difference is that AI is ML done in PowerPoint. Let's use these to build a future that we want to live in, right? Instead of using data and building machine learning models that carry forward the world that we lived in or the world that we live in now, let's do what we need to build the world that we want to live in the future. Sounds good? All right. Hey, that is it. My talk. I am done. Thank you. If you didn't hear the question was, can we use monitoring data drift as a way to measure or monitor for bias? So if you don't know what data drift is, right, data changes over time, and so our models age, and then they eventually need to be refit. And that is something that's absolutely necessary as part of your machine learning lifestyle cycle or model management process, whatever you want to call it. I would say that it's probably necessary, but I wouldn't say that it's sufficient in order to cover the question of bias in your data. I think that bias requires some other special attention. And one thing that I really like that I didn't mention, but since I'm talking about model lifecycle management now, I will. When you build a model, it's really cool to build a model card with it. And the idea of a model card is the person that built the model annotates out like, this is how the model should be used. These are the biases that I know about. This is what'll make the model break. It's a really clever thing to do so that if your model becomes really popular and it's used for other stuff, you know, at least there's some sort of artifact that like, this was its intended purpose and, you know, this is sort of what we warranty. All right, any other questions? Yeah, that's a question that I've struggled with too, right? So, and if you didn't hear it, the question was like, as a data scientist, we should report what the data says. I agree with that. I think that reporting what the data says and is cool and okay. I think that talking about all of what the data says, including fairness and unfairness, is okay. It's good to be transparent. Transparencies I would always encourage. I would say where I would add on to your statement is, yes, but when we move from reporting on what has happened to making decisions, prescribing what should happen, that's where we want to be especially careful that we don't continue to do the things that maybe we did that we don't like. So absolutely report, absolutely discuss, be transparent. But when we're putting some model into production that's going to make decisions on what happens to people in the future, that's where we want to be especially careful. Well, yeah, and so when you're reporting on what the data says, right, shouldn't you also report on how the data was collected and how it maybe was miscollected? And be skeptical of it, right? There's probably more statisticians in the room than me, right? And anyone that has a base in statistics is a really good skeptic. So like engage that, be a skeptic.
Okay, well, keeping things moving along. Thank you very much.